Right. So the experiment now we are going to deal with is bifilar pendulum. Bifilar pendulum ante it is a pendulum connected with two threads, two coils అంటే రెండు strings తో దీన్ని కనెక్ట్ చేస్తారు. So this pendulum is connected with two strings. Okay. So what is the purpose of this experiment is the purpose of the experiment is to measure the moment of inertia of the object. So మనకి ఏదో ఒక given some object and we have to find out the moment of inertia. Okay, inertia అంటే ఏంటంటే what is inertia? So there are two threads. So what is inertia? Inertia అంటే ఏంటంటే న్యూటన్స్ ఫస్ట్ లాలో అక్కడ వచ్చింది. The object when there is no force, object continues to be in its state of rest or uniform motion అని చెప్తాం. అంటే ఏంటంటే రెస్ట్లో ఉన్న ఆబ్జెక్ట్ రెస్ట్లోనే ఉంటుంది, మూమెంట్లో ఉన్న ఆబ్జెక్ట్ మూమెంట్లోనే ఉంటుంది. So that property is called inertia. Okay, and what is the control parameter for inertia? Inertia control parameter ఏంటండి? I mean who controls inertia? So let's say some object has more inertia, some object has less inertia అనేది ఎట్లా చెప్తాం? We'll take two examples. I'm taking a lorry, a heavy vehicle. Okay, ఒక హెవీ లారీ ట్రక్ ఉంది, ఫుల్ లోడెడ్ ట్రక్. దాన్ని స్టార్ట్ చేసి మూమెంట్లోకి తీసుకురావాలన్నా కానీ కొంచెం కష్టం, టేక్ సమ్ లాంగ్ టైమ్. అండ్ టు స్టాప్ ఇట్, even if you apply brake, it stops at a very long distance. So I can say it has more inertia compared to a small bike, a small scooty. I can start it and bring it into motion quickly, and if I apply brake, it comes into rest very quickly. So ante entande, so inertia is controlled by mass. More the mass, more is the inertia. Antena? So inertia is controlled by mass of the object. Okay. So alage coming to the rotatory motion, the corresponding equivalent parameter is moment of inertia. So it deals with how better an object can be brought into circular motion. So normal inertia deals with linear motion. As coming to circular motion, we call that parameter as moment of inertia. So that moment of inertia is given by mass times area. Okay, so more the area of the object, more is the inertia. So ante entande, it is a bit difficult to bring this object into motion. సో ఇప్పుడు దీన్ని ఇలా తిప్పాలనుకున్నారు. ఓకే, లెట్స్ సే దిస్ ఈస్ ద ప్లేట్ అండ్ దిస్ ఈస్ ద ఎక్స్ అండ్ వై డైరెక్షన్స్. లెట్స్ సే దిస్ ఈస్ ఎక్స్ అండ్ దిస్ ఈస్ వై. ఓకే, సో టు బ్రింగ్ దిస్ ప్లేట్ ఇంటూ సర్క్యులర్ మోషన్, యూ హ్యావ్ టు రొటేట్ దిస్ లైక్ దిస్. ఓకే, దిస్ ఈస్ వన్ పాసిబిలిటీ. అనదర్ వే, లెట్స్ సే దిస్ ఈస్ జెడ్ డైరెక్షన్, ఎక్స్ అండ్ జెడ్. ఐ వాంట్ టు రొటేట్ ఇన్ దిస్ ప్లేన్, xz plane. So ఇప్పుడు దీన్ని రొటేట్ చేయాలంటే I have to rotate this entire plate like this. Okay, so which is easier for me? ఈ xz plane లేదు xy plane లోనా? Which rotation on which plane the rotations are easier for me? xy plane లో ఈజీ అవుతాయి, yz plane లో కొంచెం కష్టం అవుతుంది. ఓకే, సో దిస్ moment of inertia is given by mr square, and for a rectangular slab this is given by x square plus y square by 12. So let's say if you are considering xy plane, moment of inertia along xy plane is mx square plus y square by 12. The same way I yz y square plus z square by 12. I zx m times z square plus x square by 12. Okay, so all the three possible directions. This is yz plane, this is xz plane, this is xy plane. Okay, so that is moment of inertia in all the three directions. And if you see, let's say if one side of the slab is negligibly thin, ఇప్పుడు ఒక సైడ్ మాత్రం చాలా థిన్గా ఉంటే పరిస్థితి ఏంటి? సో ఇఫ్ యూ మెజర్ దీస్ లెంగ్త్స్, the length of this z direction is 1 centimeter. Okay, so along the z direction this has a width of 1 centimeter, and along y direction 9 centimeters, and along x direction it is 14.5 centimeters. So x is 14.5, y is 9 centimeters, z is 1 centimeter. So if one side is negligibly small, ఏమవుతుందంటే x square plus y square is what? 14.5 square plus 9 square. So it is nearly 200 plus 80, 81. So this value is around 280. I mean, I am neglecting this m by 12. So I am just calculating x square plus y square. What about y square plus z square? This is 81 plus 1. This is 281. 14.5 square ఎంత చెప్పండి ఒకసారి, కన్ఫర్మ్ దట్ వన్స్. 14.5 multiplied by 14.5. 15 square is 220. What is 14.5 multiplied by 14.5? 210. Okay, so 210 plus 81.4. Okay, neglected. So it is 291 here. This is 82. What about this? 210 plus 1, 211. So if one side is negligibly small, sum of these two is what? 283, 293 is nearly equal to the largest area, a moment of inertia along largest area. Okay, so I can write this equation as Ixy is equal to Iyz plus Izx, and z is very very small compared to x comma y. Okay, in that situation the moment of inertia along xy, which is the largest plane area, will be equal to moment of inertia along the other two directions, other two planes, yz and zx. So we are going to verify this equation. Okay. So to do that, we try to generate, we are developing a pendulum using this slab, a bifilar pendulum. Bifilar means two strings. So this pendulum is connected with two strings. So we will be using a similar formula for time period of pendulum. Time period of pendulum is given by t is 2 pi root L by G. So we make small modifications to this equation and incorporate this moment of inertia and this double suspension concept also. So this equation now turns into 2 pi times Li. I means mass times area, moment of inertia, by I have to divide with some component of mass times inertia. Okay, so I am dividing with m times D1 and D2. So here D1 is the separation between the top portion of the suspension. So this separation is called D1. D2 is the separation between the bottom portion of the suspension. L is the length of the pendulum from the middle of the top suspension to middle of the bottom suspension. So L should be measured from middle of the top suspension to middle of the bottom suspension, L value. D1 separation between the top suspensions, D2 separation between the bottom suspensions, M mass of this slab. So my time period now becomes this. So what is the conclusion? More the moment of inertia, more is the time period. So if this is the time period, what happens to frequency? 1 by 2 pi gm d1 d2 by li. అంటే ఏంటంటే frequency is proportional to 1 by moment of inertia. In other words, energy is proportional to frequency, is h nu antam, frequency. So what is the conclusion we are arriving at? More the moment of inertia, less is the frequency of oscillations. And less is the energy required. అంటే ఏంటంటే సో ఈ ఆబ్జెక్ట్ ఏరియా ఎక్కువ ఉన్నప్పుడు when the area is very high, moment of inertia is very high అని ఈక్వేషన్ చెప్తున్నాం, రైట్? when the area of the object is very high, area in the rotational plane is very high, moment of inertia is very high. అంటే ఏంటంటే it is very difficult to bring that object into circular motion. అంతే కదా? high moment of inertia అంటే అర్థం ఏంటి? It is very difficult to bring the object into circular motion, and it is very difficult to stop if it starts rotation. Rotation start అయిందంటే దాన్ని ఆపడం కూడా కష్టం, రైట్? సో when the moment of inertia is very high, అప్పుడు టైం పీరియడ్ ఏమవుతుందంటే, సో వాట్ ఆర్ వి డూయింగ్ హియర్? we are trying to bring it into rotation, stopping it, again bringing it to rotation in the other direction. So oscillations అంటే అర్థం ఏంటి? So we are simply playing with the moment of inertia of the object. We are trying to test whether what is the role of moment of inertia in this story. What is the conclusion that we can arrive at? Conclusion ఏమొస్తుందంటే, higher the area, lower is the time period, because it is very difficult to move it. Right. So ఏం చేస్తున్నామంటే, we are trying to bring it into circular motion, stopping it, getting it back, again into circular motion, again stopping it. So we are simply playing with moment of inertia of this object. So ఏమవుతుందంటే, more the area, more is the time period. So more the moment of inertia, more is the time period. So that is the conclusion we arrive from this experiment. So we are confirming that if object has more the area, it is very difficult to bring it into circular motion, and once if it comes into circular motion, it is very difficult to stop it. So so what are the variables? I mean, we have to calculate, we have to measure Ixy, Iyz and Izx using this equation. So how to get value of I ఎట్లా వస్తుందంటే, from this equation, so t square by 4 pi square gm d1 d2 by L. So this is the expression for moment of inertia. So ఇప్పుడు ఇందులో వేరియబుల్ ఏం తీసుకోవాలి? So we have to measure Ixy, Iyz and Izx. Along the three directions we have to measure moment of inertia. So take one particular direction. Let's say this is, what is this? YZ plane. So now the suspension is along YZ plane. right? So along YZ plane you have a particular D1, particular D2, particular length that also can be set, fixed. So once you fix that, you will get a value for time period. So దీనికి table ఏం కావాలంటే, what is the table? I value theory. So otherwise develop this. What is this? The plane that we are considering here, it could be xy or yz or zx. I mean, you have to write those distances. X is 14.5, y is 9, here y is 9, z is 1, and x is 14.5. These are the three possible planes we are considering, and from this I. So you have to calculate this IXY, IYZ and IZX. IXY is, IYZ is, IZX is this. This is theoretical calculation, and we have to compare this theoretical calculation with experiment. So what we have to do? We have to measure L, D1, D2, and mass can be set outside. M is around 450 grams. You can measure and confirm that. Then G value 980 centimeters per second square. What else is remaining? Time period. So we have to measure the time period. So for that I measure time period for 10 oscillations. Trial 1, trial 2, 10 oscillations, and average for 10 oscillations. Time period. Time period is average by 10. So time period is T average by 10. Then I can substitute everything and get the value of I. So I can substitute everything into this equation and get the value of I. So I got M, D1, D2, G, L, right. So this is the table. So theoretical values and experimental values. You should compare and finally verify this equation. Okay. So what is the order of the numbers that you get? M R square. M is 450, R square is around 300. So these are the type of the numbers that you come across for I. Okay. So finally, what is the conclusion? I mean, when you try to, let's say oka plate edo teeskunnaru, disc lantiది, discus throw. When you try to rotate it, when you try to throw it away, ఏం జరుగుతుందండి? I'm not throwing it, okay. So when you try to throw it away, it is very difficult to push it, and when you try to stop it, already when it is in the flying mode, it is very difficult to stop it. When the plane of rotation has maximum area. In the other way, మీరు ఇట్లాగా రొటేట్ చేయడానికి ట్రై చేశారు, it is very easy to rotate it in this direction, whereas in this plane it is a bit tough. I mean, if it is in this plane, it is a bit tough, whereas if it is in the vertical plane, It is very easy to rotate it and it is very easy to stop it also. So that is the only conclusion. When the area is very high, moment of inertia is very high. So we need to put in more energy. That's all. Okay, we'll verify that. So to calculate the time period, what shall we do? We have to start counting. Let's say if it is like this. Let's say if you start counting your 0 here, 1. So it will go to the other end and come back. So 0, 1, 2, 3. So like that will count. Okay, so you have to perform this experiment in all the 3 directions. So x, y, y, z, z, x. Okay, your suspensions are there, you can continue with your experiment. So here we perform this experiment by calculating moment of inertia using this formula. Means xy, we consider one plane xy plane and calculate moment of inertia in xy plane. Then calculate moment of inertia from the experiment. So for this moment of inertia we require a t, g, m, d1, d2, l, all these values. 4 pi square is a constant. So we are taking g as 980 meters per second, m value 450 or whatever, you can measure it and verify. Then d1 is the separation between the top suspension points, d2 is the separation between the bottom suspension points, l is the length of the pendulum. So you have to measure from center to center of top suspension to bottom suspension. So since these 2 strings are slant, you cannot measure the length of the string, you have to measure the vertical distance from top suspension to bottom suspension. And here one important observation is this energy. So if you see the equation, time period is proportional to moment of inertia. In other words, frequency. So in other words, frequency is inversely proportional to moment of inertia, or I can say energy is inversely proportional to moment of inertia. So but we have 2 equations that relate rotational energy with moment of inertia. So one is this half I omega square, so which is equivalent to kinetic energy, rotational kinetic energy. I mean, if you write kinetic energy as half mv square and multiply r square and divide with r square, so we get half mr square v square by r square. So this mr square can be written as I, moment of inertia, and v by r can be written as omega, angular velocity. Omega is v by r. So in total, rotational kinetic energy is half I omega square. So from this equation, E is proportional to I. Another equation is this can be written as E is equal to p square by 2m. So E is p square by 2m, and if you write, if you multiply with r square on numerator and denominator, this can be written as E equal to L square by 2I. So p square r square is L square, 2m r square is 2I. So E is L square by 2I. So here it is E is inversely proportional to I. So which one should we consider is a matter of discussion. So from these 2 equations, if omega is constant, if angular velocity is constant, E is proportional to I, and if L is constant, angular momentum is constant, E is inversely proportional to I. So in this situation, in this experiment, what is that remains constant? Either omega or L is a matter of discussion. So when does that L remain constant? L ఎప్పుడు కాన్స్టెంట్ ఉంటుందండి when you have isotropy in space. That means if the object executes circular motion, the object experiences constant potential as a function of r. So for a fixed distance from a center, if the potential energy is constant, the object executes circular motion, and as long as the object executes circular motion without any external force. So if the torque, if the rotational force is 0, if there is no external force, that is what we are doing here. We are just giving a push to the pendulum and removing the external torque. So there is no additional rotational force acting continuously. So as long as this torque is 0, dl by dt is 0, or angular momentum remains constant. So this is equivalent to Newton's first law. As long as force is 0, momentum remains constant. The rotational equivalent for that statement is, as long as torque is 0, angular momentum remains constant. So in this experiment we are just pushing the pendulum and removing the torque. External force is removed. So torque is 0, angular momentum is a constant, so energy is inversely proportional to moment of inertia. That is what we are observing here. Energy is inversely proportional to I. So in total, the aim and agenda of this experiment is moment of inertia is proportional to mass and area under rotation. So we are considering same block, metal block, but depending on the point of suspension, so mass is constant. So depending on mass point of suspension, one time we are seeing xy plane, another time yz plane and zx plane. The moment of inertia are different in different directions for the same object of same mass. So that is what we are confirming it from this equation. I mean, if you consider one side very thin slab, then you can confirm this equation, Ixy is equal to Iyz plus Izx. So this is the ultimate confirmation for moment of inertia. So once moment of inertia depends on area under rotation, higher the moment of inertia, higher is the time period. So in this experiment you are trying to play with the moment of inertia. You are trying to rotate the object and again stopping it, again trying to rotate in the other direction. So in total, more the moment of inertia, it takes more time to stop it and it takes more time to bring it into rotatory motion. So all these can be verified through this experiment. So moment of inertia is proportional to mass times area under rotation, and time period, if you try to oscillate it, time period is proportional to moment of inertia. Energy is inversely proportional to moment of inertia, and that is because angular momentum is constant in this story, and that is because we are removing the torque. There is no external force acting on the system. So torque is 0, angular momentum is constant, so energy of rotation is inversely proportional to moment of inertia, frequency is inversely proportional to moment of inertia, time period is proportional to moment of inertia. So all this can be verified through this experiment. Done.